So a diagram here, if I can redraw it, so I don't like velocities actually attached to the particle, so I can redraw that diagram here. Not very well, obviously. 0.5 meters there. That swings around. That's a circle, and so we've got the particle here. Now I can put the weights, the forces on there. That will be mg, 0.2g, and that's a string, so the tension is going to go straight in there. And there's no other forces acting upon there. And I know that its velocity here is v, and its velocity here is u. And that gives me that angle there is theta. And I need an acceleration going inwards. Acceleration equals r omega squared, or v squared over r. I'm going to leave it at that one because that's the one I'm going to be using. Because this can be to do with energy. But show that when a string is taut, the tension is given by this. So T equals, well, I'm going to do that. I've got to resolve going inwards, so I might as well resolve going inwards right from the beginning. So I'm going to resolve going inwards, and I've got resultant force equals mass times acceleration. So resultant force, what goes in? I've got T, but I've got this part of the that part of the weight going back negative, so that'll be minus 0.2 g, that's theta, that bit will be theta there, so cos theta. And that will equal the mass, 0.2, times by the acceleration, and the acceleration, I just said, is v squared over r. And r is 0.5, so v squared over 0.5. So it's done the first little bit. And now I need to find out what v squared is, and I'm to do that by energy. So total initial energy equals total final energy. And I've got potential energy and I've got kinetic energy. And I like writing at least a bit of the formulas out here so I can make sure I don't slip up and forget the h or forget the squared in there. So initial energy, it's got no potential energy, so 0 plus a half times by the mass, 0.2, times by initial velocity, u squared, and that will equal mgh, 0.2 g times by h, and that is going to be 0.5 is the whole thing here, but I'm going to have to take away this bit. I'm going to take away this bit here, which is 0.5 cos theta. So that would be 0.5 minus 0.5 cos theta, and then plus a half times by m, which is 0.2 times by v squared. And I'll just work all this bit out, and that gives me 0.1 u squared equals 0.98 minus 0.98 cos theta plus 0.1 v squared, and so that will give me that v squared on times through by 10, v squared equals u squared minus 9.8 plus 9.8 cos theta. And that's nice now, because now I can combine that, and that v squared can go here, and that will give me that t equals, t equals, that's 1.96, so t equals 1.96 cos theta plus 0.4 u squared minus 3.92 plus 3.92 cos theta, so t equals 5.88 cos theta plus 0.4 u squared minus 3.92 as required. It's done the first part, and let's see if I can put the second part down here. So part 2, I can do it in a different colour, I'll do it in red. So part 2, it wants us to find the least value of u for which the particle will move in a complete circle. And therefore we've got to get, the t has got to be So t must equal 0 when it's at the top. Theta equals, at the top, that will be 180 degrees pi radians. So that's what I've got to put in there and just substitute it into here. So 0 equals 5.88 cos pi plus 0.4 u squared minus 3.92, and that gives me that 0.4 u squared equals 9.8, and so u equals square root of 24.5, which is 4.9497478 or something like that meters per second. Obviously we put down there, I'll do it anyhow, 4.9523 significant figures. Good. Okay, so we'll do part 3 up here. Given in fact that u equals 3.5, well, it's less than that, find the speed of the particle at which the string first becomes slack. So u equals 3.5, and find when t equals 0. So I just put it into my t formula, which I worked out earlier. So that gives me 0 equals 5.88 cos theta plus 0.4 times 3.5 squared, that's a u bit, minus 3.92, and that gives me that cos theta equals minus 0.98 over 5.88, which equals minus 0.1666, etc. And so theta equals 1.73824446. But that's not what we wanted. That's when it happens, when it's 1.73. But we need to find v. So find v when theta equals that. And I use my formula, which is here, which is v squared from the first part. So v squared equals u squared, which is 3.5 squared, minus 9.8 plus 9.8 cos of that angle there. And so that gives me that v squared equals 0.81666. And so v equals 0.903696114, which equals 0.904 meters per second. And that becomes slack. And that's question 7 done on a pretty straightforward paper. And that's it.